Okay, it's another Monday, it's 9 o'clock sharp again in the morning, and I'm super excited to do another one-day build. I'm gonna make something and let's see, hopefully we can make it work in one day. If not, then we will never know. And today I have something totally different. I have this flip clock, old Italian, super nice, and I got it over a year ago, and it flips every minute to a new number. I never came around to use it. I don't know how it works. It has some sort of plug on the back side, but no idea how it works. So we need to find out that. We need to see if we can make it sync the time or maybe give it some extra features. And it could have some cleanup. So yeah, let's see how far we get and how everything is put together inside of here. So I got a screwdriver, there's one screw at the back, and hopefully that can tell us how it's put together. And let's see. Yes, okay, complex, I can tell you that. Yeah, a lot of knobs and bips and bobs, and I think if you turn this, yeah, you can hear it click, and then at the end it makes this go around, and then at the end of the day it goes back to 0 0 0, and this is the whole mechanism. So we need to see how we can make this turn, hopefully through its original coil. And maybe something so we know at what time it is. If I take out the clock and then later put it back in power, that it still knows what time it should display, and it will not continue where it was left. Yeah, let's give you a closer look. Okay, so I think I figured out what these numbers and this mean. If I have 1 and 2 and 3 and 4 connected, I can power it with 24 volts. And 48 volts, then I need to only connect 2 and 3 together. And these are the plugs that go outside. Okay, so I had a look online and I found that, yeah, if we switch the pins every minute, then it should go to the next flip. And that basically means that this clock is not as much a clock on itself, but it's more a slave clock where there's another control unit, and then you have multiples of these around your company or around a public space, and they all wired to this master clock, and that gives the signal every minute. So now we need to fake this master signal, and one way to do it is with a motor driver, because basically these coils are quite similar to a motor, so you either power it forward or reverse. I will have you have a better look. Okay, so basically we need to power the pins here with this coil, and we need to switch it often. So we're gonna use a H bridge that switches the plus and the minus every minute, and then it should be able to tick the clock. So let's see if we can make a very basic setup. This is an output component. So this should be able to switch it. Still a bit big component, but maybe in the end we can use something smaller. But just for testing purposes, this should be good. We can put power in and then switch it around on these pins. And then we're gonna use something simple as a Arduino Uno, just to write some few lines of code to see if we can make this work. And later in the end, I might use a Wi-Fi module so I can get time from the internet and sync the clock, or maybe add timers or other ads. But for now, just to test it, we're gonna use the as simple as possible driver and IC. So let's see if we can wire something up and make it tick. Let's head over here. Let's set up the camera on the overhead. So that should be like this. I uploaded the code to the Arduino. It's just 10 lines, putting one pin high or the other pin high. If we now measure it with the multimeter, difficult to see probably, but it says 20 and minus 20 and 20 and minus 20. So if we now put this on the pins, we should, yeah! Do you see that? Fuck yeah. Okay people, we are 20 minutes, no 20, we are 1 hour in the build. Ooh. We are 1 hour in the build and we already have a ticking clock. It is now switching every 2 seconds. Yeah! Okay, now let's see if I can make it view from the front. Oh, it wants to do. Wait. I'll give it a bit more power. This should be good. And let's see if we can make it pop. This one here. Oh yeah, it's happening. It is just 10:05 and we have a ticking clock. 20, 21, 22. Okay. Perfect. Let's see here. Components are not getting too warm. Okay, let's head on over to the next step and see how we can verify at which number it is. So now, if I turn the clock off, it will forever be 15:23. So if I turn it back on, I want it to be able to know that it's 15:23, or go to a place where it knows where to start and then give the right amount of ticks to set the current time. So let's see. It would be cool maybe to add maybe an infrared sensor here, just to measure if it's open or closed, to see if it actually made the tick. Only problem with that is it can verify if it made a tick, but it still doesn't know what time it is. So now I'm thinking maybe we should go to the hours and check at what time it's 00, and then see, measure if the okay, recap. So maybe it's better to look at the hours and see at what points it flips from 23 to 00, and have that as a reference point, and then from there on do the required ticks in order to get the current time. Because there are some interesting shapes in here that can indicate like what time it is exactly. Okay people, we are making progress. Every second a new tick. It's about to go to the second hour. Boom. And I found that this is the part for the seconds, or for the minutes in the end. This is for the hours. This is so it flips from 23 to 00. But I also found that this little notch goes down all the way to the end until it's 12, and then it springs back up. So maybe if we use a small limit switch here, we know when it's 00, and then we know the at what point the digits are, and from there we can sync the time. So let's just fast forward a couple of hours. It is a bit loud, but I think with the case around, it's not so loud. It is now 2:52, so let's make that 6, 7, 8, 9, 10, 11, 12, 22. Okay, put these back in place, and now let's turn this again. And then 55 something, almost 23. Yes. Okay, and now you can see that this is already a bit lower. And when it is 00, it will spring back up. So let's see, 18. Half an hour more. Okay. So we will just count down. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, kadang. Okay, modeling. Let's see if we can make something fit. Man, I love this machine. So it's rather difficult to reach here because it's all in here. But it turns out if you turn this one and the same on the other side, you can take the outside off and enter the internals. And we can later clean the glass. Also turns out that it's symmetric. So all the paint and nastiness that was on top, maybe we could sort of hide it at the bottom. And now we can easily enter here. Perfect. Okay, so it's just after 12. 3D print is done. And it didn't print fully correctly, so I need to make some improvements. But we can check if the push button fits in. That fits snugly, doesn't fall out. It can still move. and then we can see if it fits around here. So the idea is that this goes around the eye, clicks into place. Still some play, so should change this a bit. But now we can move it, put it in the housing, and put a little dab of hot glue just to see if it's correct. And I will add some wires to make it a sensor. Okay, so the printer is printing in the background there, and let's have a look on the housing. So it seems there's some white paint or something, because the inside is very nice cream clear. The outside has some spackling, and then the front is this aluminium casted part where it has this ring on the inside and this clear plastic part. Also has some dirt spots. So let's first see if we can get rid of that with just some normal alcohol. Oh yeah, nice. Okay, it seems like somebody tried this before already, because there are some scratches. Okay, so we made all the hardware modifications to the clock. We now have a ticking clock and we can read out when it's 00. Now I want to see, together with the back cover, if we can make a nice stand for it to put it on the table. So if we disconnect the sensor, this is the clock, and it has this super nice back panel. You know, people put effort in it when they make screws that stay in place if you loosen them, so you don't actually lose the screw itself. And it's just so much love and effort that's put into this. It's great to see. And now the idea is to have it like a desktop clock for now. It has this funky screw where I'm not exactly know what it's for. It has this set place, and as far as I can see, yeah, you can determine the angle, but I guess it's more for a stand to have it next to a to have it next to a table or something. But I want to have it on the table itself. So I think I'm gonna get rid of the screw for now, and then 3D print something with the same shape as this, and then have this screw be able to hold the 3D print to the rest of the clock. So yeah, let's do some more 3D modeling and see how we can make this work. So if you Google for the Shifra 5 clock, you will get lots of clocks, Philips clocks. If you don't do the clock, it's just the number 5. And from here you can see that indeed it has some sort of feet base that's quite square, seems like it. And we should be able to mimic something like this. if you have a look on eBay, you don't find the clock itself, but what you do find is the actual feet. So if everything else fails, I can just still buy this, I think. But this is roughly how it should look like. So it has the hole in the back to put the screw in, and then it's just feet. And here's the same from the other side and from the front. So let's see if we can make something like this. I'm gonna make it a bit simpler because we're not gonna see the back of the clock often, and it just needs to function. So yeah, let's see. Fusion, show the origin, start with a new sketch, and then we do a center square. Let's see, it should be something roughly 70 millimeters wide. And yeah, let's do 140, so it's double the size. What we could already see is that it has rounded corners. Now, let's first extrude this, and then later kill it with a fillet. And voila. So I cut out the shape. And now let's see if it will fit. Oh yeah, this is good. So you can see there's just the right place where it will fit. And then it's also easier for us to locate where we should have the hole. So yeah, this should work out. Thanks, printer. So this is where we left off last time. I did a print and it seems to fit rather nicely. So now we need to make the hole. I made a sketch, which you cannot see, sorry. I made another sketch. And with this sketch is in the middle, and this should be able to have the screw hole in there, and this will be just a revolve cut, so then the feet will look roughly like this. And then if we hollow it out, it becomes something like this. Yeah, all in all, very simple. Hopefully it will fit nicely. And let's send it over to the printer. Just you can make it a 0.2 quality PLA 15% infill slice. A print of just over 3 hours. So that should still fit in today. And let's see if it works. It's printing. Print is finished. Nice. Bit warped, but good quality. And let's see if it fits. Oh, take the screw out. Oh. Easy. It's already getting late. Quarter to 10. This goes here. Close it up. And then for the big test, let's see. 1, 2, 3. Oh yeah, nice. Yeah, this looks very good. So you can clearly feel that there's one way how it fits, and it seems solid, so that's good. And I can have a look how the screw would fit, but I guess I'm pushing my luck. Let's see. This fits in here. Oh shit. It might actually fit. No way. Yeah. Screw fits nicely in there. And now pick it up again. Yeah. Look at that cute feet. Oh yeah. Nice. Print it in one go. Okay, there's a slight gap, but other than that, it's nice. It's stable. You can see the light well. Looks cute. Perfect. Now let's head back over to the code and see if we can program it with a Wi-Fi chip in order to get it the time and then sync the time every time it's connected. Cool. Okay, so I connected everything up and we have the power supply and then the Arduino that runs the code and then a motor driver that runs the coil. And I also added in the limit switch, so as soon as it's 12 it should now stop ticking, because that's what I programmed it, and then later on we can make it so it can get the data from the internet. But for now, let's see, it's now at 21:02, so I sped it up. Every fifth of a second it flips. So let's see if it works and if it stops at 12. So let's turn it on. Oh. Oh boy. It doesn't want to turn anymore. Okay, this wants to turn. Maybe there's something wrong in my code. Could also be. Let's try it one more time. Ah, okay. And let's do it one more time. Oh no. Okay. Let's see. Oh, okay, I found the problem. The limit switch is loose again. There's too much, but wait, let me show you. So I thought I made it solid enough, but now I see that there is quite some play, so that could be the problem. Let's wire things up differently and then see if we can have digital readouts on the computer. Cable to this and I'll power it from here, but from here. Okay, nothing blue, that's good. And then it says live debugging. It says it's still Oh, no. Ah, yes, yes. Okay. It should work now. It should work. Yeah, let's see. If I turn this on. It's flipping. Yeah. So here you can see the mechanism. And here you can see it's almost 12. And let's see if the limit switch will work. And there's the Arduino. And there's the code. Almost. One more hour. Whoa. Let's see. It stopped. 2702. I think it's close enough, because if I do this, it goes back to 0. The only thing is the O2. So it's too much. So maybe I should do it in the beginning. But other than that, seems good. I'm very happy. We're making progress. That's good. Back to the code? Yeah. Let's go back to the code. Okay, so every time it would flip over, it would stuck at 27. And I had no idea why. I thought the case was fully symmetric, but it turns out that around here and around there is a small notch, so this part can fully twist. So we should flip it around, and then it should fit back together, and it should flip the 27 more. And it's that time of the year again. Okay, so far for the coding. Okay, it's 11:45 and everything is still here, so didn't fully work out. The stand is there. I shrunk the components, so it's a bit smaller now. Every 10 seconds it gets the time from the internet, and it is able to measure if it is 12 o'clock or not on the clock. So we can now see it's flipping. And soon it will flip over again. Nice. And let's see if it can detect the 12 o'clock mark. Okay, it's really close now, almost 12, as you can see here. So it is about to go. 3, 2, 1, yes. Okay, after this it's okay. Nice. Okay, this is where I'm gonna leave it for tonight. I made the base, cleaned it up, used the internet controller. It can get the time, it can read the sensor, and it can give the right pulses to the motor controller. This one is still a very big one, but I will get a smaller one later, but that just takes time to arrive. And I got a power supply, and I can find another 24 volts to have it a bit smaller and more compact. So for now, if I add this and I release this, it turns every 1/4 of a second. And it can sense when it is at 0.00. So that's it for tonight. I'm gonna get some sleep and hopefully not annoy the housemates any longer with this clicking sound. See you! Hey guys! So I started working on the flip clock again. It's a few days later now. And I did some research and I found that I could use this motor driver, which is a lot smaller, and I can put it in the base of the clock. Only thing is it's sold out, so I need to wait a bit until it arrives, and then I will place it in the mount. Until then, we will just keep using this one. In the meantime, I started working on the code again. So now the code, everything fits on one page. And I made some small adjustments, and I will explain you why. So let's say it's 9 in the evening and you turn the clock off for some reason. So it's at 21.00. And let's say you turn it back on again at 9:20. Then what the clock doesn't know at which position it is. So it will first flip until it reaches 00, which is already 3 times 60 flips. And then it will recognize that it's at which position it is. And then it can count how many positions to do until 9:20. So that would be 21 times 60 plus 20. So that's almost 1400 ticks. And then at the end it would display 21:20. So this whole thing would take a lot of time, and it would start at 21 and end at 21:20. And it would pass one time just to know that it's at 00, and then continue to 21. So it's a bit difficult, but it would work. It would only take a long time. So what I changed now is that every minute the microcontroller saves the current time. So let's say it's 21:02, you turn it off, and because it saved the value in its flash memory, it will recognize it when it boots up. So when you turn it on, it will sync the time, and let's say it's 21:20, and it knows that it was turned off at 21:02. So then it can do the math and know that it only needs to do 18 ticks before being at the right time again. And this makes it a lot easier, a lot faster, and a lot more pleasant for everyone. So I now implemented this one. So you can see some things to load config values, to save config values, to sync the current time, and to set it to the correct time. And then from there on it will loop every minute where it will tick and it will save the status. And yeah, with that, the whole programming is done. I can upload it and have a web syncing clock, flip clock. See you!